Recording progress.
This video will cover the Test 3 review guide for geometry. So a quick review of section 3.1 are the different angles, which angles are corresponding. Now, as you can see with line L and M, these are not parallel. However, we do know if they are parallel, that these become very important angles. So right now, corresponding, if I start with 1, then the corresponding angle, angle 1, and its match is angle 3. We also have angle 2 and angle 4, angle 5 and angle 7, and then last we have angle 6 and angle 8 are all corresponding. So if they are parallel, we know that corresponding angles are congruent. So just using the first as example, that means the measurement of angle 1 will be equal to the measurement of angle 3 if the two other lines besides the transversal are parallel. Alternate exterior, we have two sets. We have angle 1 and angle 8. Oops, got myself there. And then we have angle 4 and angle 5. We also know if those two lines are parallel that the alternate exterior angles are also congruent. So the measurement of angle 1 would be equal to the measurement of angle 8, as well as 4 and 5. Alternate interior, we have our interior angles alternate on opposite sides of the transversal. And those are angle 2 and angle 3. Excuse me, angle 7. And then angle 3 and angle 6 are alternate interior. Alternate interior angles are also congruent when the other lines are parallel. So the measurement of angle 2 would be equal to the measurement of angle 7. And last we have consecutive interior. So consecutive means that they're on the same side of the transversal, but they're inside of the other two lines or in between the other two lines. So these would be angle 2 and angle 3, angle 6 and angle 7. And these are supplementary. So angle 2 plus angle 3 would be, or their measurements, excuse me, if those were parallel lines, would be equal to 180 degrees. Okay, so just a quick review of that. And then using that information to solve. So in this case, we know we have two parallel lines because they're notated here with single arrows on both. So we want to find the value of x that guarantees that A and B are parallel, given that the measurement of angle 5 is 3x plus 9, and the measurement of angle 7 is 4x minus 3. So 5 and 7 are corresponding angles, so we know we can set up an equation stating that their measurements are equal. So 3x plus 9 equals 4x minus 3. I'm going to actually move my variable over here. And so I'm left with 9, but that's not a 4, that's 3, with x minus 3. And then to the final step to isolate my variable, x equals 12. So the value of x that makes those parallel is 12. And then the measurement of angle 6, so you can go about it two different ways. We know that angle 6 and angle 5 are a linear pair, so their sum equals 180. But using what we've learned in this section, I'm going to go ahead and use angle 6 and angle 7. These are consecutive interior, so we also know in this case that their sum is equal to 180. So if I find angle 7, I can then subtract that from under 180 to find the difference, which is going to be my measurement of angle 6. So start off with the measurement of angle 7 equal to 4x minus 3. Supplement or substitute in that 12 for x. And I find that measurement of angle 7 is 48 minus 3, which is 45 degrees. I can use that then to have 180 degrees minus 45 degrees, and that gives me 135, which is the measurement of angle 6. The measurement of angle 6 is 135. I'm also asked for the measurement of angle 4. So again, we can come at it from two different ways. Angle 4 and angle 5 are alternate exterior angles. But since I've already calculated the measurement of angle 7, I know that 4 and 7 are vertical angles, so they're also equal to each other. So if the measurement of angle 7, again, measurement of angle 7 is going to be equal to the measurement of angle 4, that means that it's 45 degrees. Okay, this one is very important. Also, I apologize, it got messed up. So there should be that's angle 12. At the top is 1, 2, 3, 4. At the bottom is 9, 10, 11, 12, 13, 14. So this one is very similar to one you're going to see. So what I want to do is they've given us the measurement of angle 12 and they've given us the measurement of angle 4. So I'm going to go ahead and put those measurements in there. Then I'm going to look at my graph. I'm not kind of going to ignore the questions being asked. If it'll let me zoom in. Nope, it's not going to. All right, I'll do the best I can. So I know that angle 12 tells me is 89 degrees. So the measurement of angle 4 is 41 degrees. So let's go ahead and figure out which ones we can learn from angle 12. So angle 12 and angle 9 are vertical angles. So I know that angle 9 is also 89 degrees. And if I have these two parallel lines here, then I can kind of ignore this line here and just look at the fact that it's almost horizontal, the up and down line. That's the transversal to my two parallel. Angle 4 and angle 10 are alternate interior angles. So angle 10 would also have to be 41 degrees. Once I know that, I can calculate the rest of this because those are all, well, it's not a linear pair, but their sum is going to equal 180. But right here is the one that I know for sure. Those equal 180 as well. Also, you could see that angle 10 and angle 13 are vertical angles. So I know this one is also 41 degrees. And so just taking 180, subtracting 89, that's going to give me 91. And then subtract 41, that's going to give me 50. So I'm taking away the 89 degrees and the 41 degrees from 180. So that tells me that what's left is 50 degrees. If 14 is 50 degrees, that means that 11 is also 50 degrees. Now that I know those, I can figure out all of the other ones. I know that angle 2, it's a vertical angle to angle 4. That one's also 41. And 1 and 2 are a linear pair, and 3 and 4 are a linear pair. So if I do 180 minus 41, that's going to give me 139. So that means that angle 3 is 139 degrees, and angle 1 is also 139 degrees. So these last few that we have, you can go about it two ways. So we have to be careful that we use the correct transversal. So I can't do angle 7 and angle 9 unless you know that angle 7, that is going to be congruent to angles 9, the sum of 9 and 10. So you could add those together. However, I think we can go about it a different way. I know that angle 6 and angle 14, these two here are alternate interiors as long as this is the transversal. So if angle 14 is 50, oops, that's a 6. Angle 14 is 50 degrees, then angle 6 is also 50 degrees. Angle 6 and angle 5 are a linear pair. So angle 5 would be 130 degrees, because 180 minus 50 is 130. And then I've got vertical angles here. So 8 is also 50 degrees, and 7 is also 130. So we found the measurements just by knowing two of these and knowing that those two of those lines are parallel. We can treat the other two as sort of separate transversals to determine the measurements of every single angle here by definition of vertical angles, definition of linear pairs, as well as the rules that we know about consecutive interior, consecutive exterior, alternate exterior, etc. All those different angles. So we can plug those in over here if you want. 13 we determined is 41 degrees. Angle 9 was 89. Angle 5 was 130. Angle 11 was 50. I believe angle 6 and angle 8 also were 50. 6 and 8, they were, yep, 50 degrees, 50 degrees. So just because there's so many, you can still kind of just start with what you know. And if you want, you could even draw those as two completely separate. You could draw your two parallel lines and then pick a transversal. We could do one like this. Oh, I made that like really big. Hold on. Let's give ourselves some room here. So that's one where these are our parallel lines. And then the other one would be something like this, parallel lines, and then we have this guy going through. So you can break it up if you would like, so that you're just using the two parallel lines with the transversal. And then, not that I can draw a straight arrow right now. There we go. Something like that. So you can kind of break it up if you need. Whatever it helps, it makes sense, because that does get very messy very quickly. All right, so let's go ahead. This next part, y'all had that on the quiz, so I didn't include it on the test. So I'm just going to skip that for right now. I didn't do it in class. But feel free to kind of use what you've got in your notes to fill that out just in case. I'm pretty confident you're not going to need it. I want to focus now on 3.4 and 3.5. So this is your 3.4 is your distance, your midpoint, and your slope. And then we'll move on into 3.5's lesson. So for these distance, I'm asking for the distance, the midpoint, and the slope of each set of each pair of, hold on, two ordered pairs. Okay. So for distance, first off, I always define my x1, y1, x2, y2. I'm going to use those in every single formula. So as long as I know which number corresponds to which variable, I can plug and chug and find all of these. So first, our distance formula. Distance equals the square root of, and here's where it starts to get crazy. Trying, sorry. So x2 minus x1 squared plus y2 minus y1 squared. Because you're adding them together, so technically it doesn't really matter which one comes first, and I can never remember. I don't have it in front of me, but this will work either way. All right, so now we plug in our x2, x1, y2, y1. Everything else needs to stay the same. x2 is 9 minus y1, which is 3, and then 10 minus 2. Okay, 9 minus 3 is 6 squared. Even though it's positive, I still get in the habit of keeping it in parentheses, just in case it does end up being negative. I don't want to forget those. This is 8 squared. So 6 times 6 is 36. 8 times 8 is 64. So 36 plus 64, neatly enough, equals 100. That is a perfect square. 10 times 10 is 100. So my answer is 10. Distance is 10 units. Wow. Word does not like me resting my hand on my computer screen. Okay, so let's go ahead and move on to midpoint. I know my midpoint formula is x1 plus x2. It's just the average of the two endpoints. Create your the coordinates for your midpoint. So again, we're just plugging it in. X1 is 3 plus 9 over 2. 2 plus 10 over 2. I think these end up being the same. 3 plus 9 is 12. 2 plus 10 is 12. So my midpoint falls at 6, 6. Easy enough. All right, last one is slope. Slope formula is rise over run. So it's the difference in y over the difference in x. I'm just going to go over. So y2, that's 10 minus 2 over 9 minus 3. 10 minus 2 is 8. 9 minus 3 is 6. Reduce. We get 4/3. Positive 4/3. So we have our slope, 4/3. The next one is exactly the same. Wouldn't be a bad idea to get some practice doing it on your own. But then just let me know tomorrow and you can check your answers, make sure you get it right. I want to move on to this next part. So when we did this on our quiz last, we actually used our y-intercept form to graph. In this case, we're going to use our x and y intercepts to then graph our linear equation. So with our x-intercepts, we know that it's intercepting the x-axis, and so y is always 0. So we know that y is 0, so we can make y 0 and then just solve for x. So 5 times x minus 3 times 0, obviously it just negates it. So this becomes 5x equals 15, and you divide both sides by 5, and x equals 3. So that means the coordinate of the x-intercept is 3, 0. I'm going to go ahead and graph that. 1, 2, so somewhere about right here. And then for our y-intercept, we know that it intersects the y-axis, which is the place where x is 0. So now it's 5 times 0 minus 3 times y equals 15. So that just gets negated, and it's negative 3y equals 15. We divide by negative 3, y equals negative 5. So the y-intercept is 0, negative 5. So start at my origin, go down 1, 2, 3, 4, 5, right here. And so now we have 2 points, and we can graph our line. We'll try. Okay, something like that. Okay, I guess the only thing that I would put here is maybe my x-intercept is 3, 0, and I'm really sure what I wanted on that. Again, number 20 is exactly the same process, so feel free to go ahead and practice. I'm going to move on into 23 and 24 to make sure that we're all comfortable with finding lines that are parallel to other, or the equation, the linear equation of a line that is parallel to another line or perpendicular. So the first thing that we have to do is we have to find out the slope of our original line. So 3x minus y equals 7. I'm going to convert it to a slope-intercept form because that tells me what my slope is. So I subtract 3x from both sides. I end up with negative y equals negative 3x plus 7. And then my y is negative. I don't want it to stay that way, so I just change the sign of everything, and that is comparable. So if that is the if that's the slope-intercept form of my original linear equation, this right here is my slope. So slope equals 3. So hopefully you remember from the lesson is that parallel lines have the exact same slope. That's why they never intersect each other. So if I look at the y equals mx plus b, I just have m. This point, this coordinate 2, 3 is on that second line. So I have my x and my y. I can plug that in plus my slope to calculate my y-intercept. So this is 3 equals 3, which is my slope, times 2, which is the x-coordinate when the y is 3, plus b. 3 equals 6 plus b. I subtract 6 from both sides, and my y-intercept for this linear equation is negative 3. So I have my formula y equals mx plus b. I plug in my slope and my x-intercept. Y equals 3 times x minus 3. There is the equation of my parallel line. All right, so perpendicular also tells us something about the slope. So I need to look at the slope of my original linear equation. So 4x minus y equals negative 6. I subtract the 4x from both sides, and I have negative y equals negative 4x minus 6. They're all negative. I want them to be positive, so I divide everything by negative 1. I get y equals 4x plus 6. So in this case, the slope of my original linear equation is 4. The slope of a perpendicular line is its opposite reciprocal. So if this is positive, the perpendicular has to be negative. If this is 4 over 1, that's what 4 is, then I flip it to 1 over 4. So the slope of the perpendicular line is negative 1/4. So again, I have my x and my y. if I use y equals mx plus b, I can plug in the y is 3, the m is negative 1/4, just calculated that, x is negative 2, where y is 3, and I can solve for b. So negative 1/4 times negative 2 gives me a positive 1/2 plus b. When I subtract 1/2 from both sides, I get 2.5 as my y-intercept. I'm going to convert that to an improper fraction. Don't mind, you can leave it that way if you want. So my new linear equation, y equals mx plus b. Y and x always stay variables in the whole linear equation because it works for every ordered pair on that line. The slope is the negative 1/4 times x plus 2.5, which is 5/2. There is my somewhat ugly, but still works, linear equation for the perpendicular line to that original 4x minus y equals negative 6. All right, that it should cover everything that you are going to see on the test. Plus what you've got in your notes will certainly help you, but that's everything. So if you have any questions, please bring them to me in class. Otherwise, we are done. Thank you very much. See you in class.